The benefits of the video, this is just us getting used to API coding and navigating ourselves around it, getting used to the tools and getting used to exactly what we're looking at. A few things that you need to be aware of, and I know that we've just talked about this now, but 1 second, got some nasty feedback. Oh no, we're all good. Right. Right, so yeah, for the benefit of the video, what we're going to do is just get used to API coding and just get used to the system for it. As I was just saying, there is a lot of APIs that are already posted out there. If you are a competent API coder, if you are a competent coder, you're more than welcome to use Visual Studio to do your compiling. If you're not, please do not try and learn it as a new software. You've got enough going on throughout the year, and it can be quite fatal if you get it wrong. As I said, I did have a student a few years ago who decided that he was going to try and learn it at the same time, and it went horribly wrong for him because I did end up failing him. Right, the other thing I wanted you all to be aware of as well, for those of you who are not the most confident coders, it's perfectly fine. I intend to try and get you competent by the end of this to feeling confident with navigating yourself around code. For those, I will be now not using Inventor for the coding side of that. That's purely because these sessions can be early doors. They're dead easy, like this one. It's a nice introduction to what we're going to do. However, once we get the ball really rolling, it can be a little bit intimidating, so I'm going to dedicate all my efforts onto SolidWorks and in essence focusing on the code itself. So without further ado, I'm going to kick into SolidWorks. Few things, first things first, you'll notice if you've opened up your SolidWorks, you may or may not have your macro coder turned on here. If you don't, going to right click, go to toolbars and make sure that you have macros enabled, and that sits under toolbars and it's under macro. You'll find a macro there. When it appears, as ever, you've got your run, stop, record, new and edit. And all we're going to do for a start is just examine the idea of a line and the idea of the line and come to an assumption of why it's doing what it's doing. You'll notice in the assignment I've asked you to look at the theoretical basis behind CAD. This is one of the reasons why. So what I'm going to do is first I'm just going to open up a new part. If I then hit on record, then go to front. Well, if I go to front, and then I go to sketch, and I go to line, and what I'm going to do is just draw a line. Come out of there, stop. And all that's going to do now is that's recorded each keystroke of, it's recorded my positioning of the mouse every time I've clicked onto it. But what it's doing is it's responding to the commands that are presently within SolidWorks for it to operate. So I'll just call this line and then click save. So I'm just going to delete that. I'm going to go edit, line. Let me just see if I can make them a little bit bigger. Right, so let's take a look through exactly what it's talking about. So a dimensioned object is essentially a tool set for us to choose different operations to it. You'll see here SWAPP as an object. An object is something that we can apply anything to. So for example, the best way to show you this is under where setting the object type. it's actually applied to the SolidWorks system. It's probably going to be easier to read it through this way, and I can show you. So submain, for those of you who are not familiar with coding, this is essentially your beginning, the start. It's the main area for starting. It then moves forwards to set the object, which has already been defined up here, because all your dimensions, all your variables must be defined. It goes to set the object, and it makes it equal to application.solidworks. Now, the application dot is a library command. This is a command that the system recognizes. Application dot refers to if there is an application that is presently open, you want to make that the active one. So in this case, it just makes SolidWorks active. Now, this again is a recognized command that SolidWorks own. Oh, 2 seconds. Yes, that's right. Semester 2 doesn't start until the 25th of January. That's absolutely right, yeah. Semester 2 doesn't start until the end of January. That's why this isn't Semester 2 yet. This is just an intro to it to get the ball rolling a little bit sooner. Right, so it runs into here and makes this the active document. So what I'm going to do is just start putting on comments. I'm going to put apostrophe and just say set SolidWorks as the active document. Then it comes to here. Now we have a second object, which is here. Now the one thing that I don't know how familiar you've been with something like this, but when it comes to setting an object that's within the present object, what it actually means is, if I minimize that, we've got the main object here, which is our software. It's the main platform. Then we have another that sits inside of it, which in our case is the part. So what it needs to do is it needs to define the application itself and also the part that's within it. So then you've got a full address process to it. So this then sets the active So now, between these two, you've got full access. This now allows you to access the new part that's presently open. Now these have been added in. Now I don't know how many of you are familiar with this, but Cosmos Works. Cosmos Works, originally SolidWorks Simulation was called Cosmos Works. And what they did is they rebranded it to make it sound more to do with the same, with the whole package, if you will. However, when it comes to the coding, there was no need for them to rebadge it because you're actually just referring to tools for it. So for me, I'm actually going to turn these off. I don't need these on because I'm not going to use them. Now, before I do anything, I'm just going to put a marker on there. Turn them off. Right, so I'll put that on there and I'll put that there as well. And now this turns them on. Now the issue is when you turn an add-in on, you must always turn the add-in off. So what you'll see here is that you've got your active ones here as well. So your study manager object. Now the study manager object is this, your study managers. Now what it's asking you to do is it's literally saying we can just turn them off. Now what I'm saying is, again, I don't need these. These are all connected to the simulation point, and I don't need these for that. So I'm leaving them turned off. And what it actually leaves me with is the raw code to run that part. Now, when I normally do anything in API coding, or when I'm automating the production of a part, I will never, ever just run in feet first. So I'll snap to the left. Now, if I want to step through, all I'll do is press F8. So F8 runs the submain. So now I'm going to set SolidWorks as the active part, as the active documents, as the active application, sorry. Then it's going to select the part and select that to be the active document. Going to go to the front plane, insert a sketch. Now, clear selection. In essence, what you'll see here, you can see there that we've got the blue line for the plane selection being turned on. Now, once we're in a sketch and we've got everything in position, you don't really need that anymore. It doesn't serve any purpose at all. So that's actually taking up vital computational memory that you could be using on other things to speed up the process of what it is that you wanted to do. So what you do is you clear the memory. That then clears it, leaves the sketch open, because if you remember on the sketch manager, all it's done is it's gone, go to the part, which we've already set to the active document, go to the sketch manager, which is a library command, which is already recorded in the SolidWorks system, then gone to dot insert sketch true. So all it actually is it's like a switch. It just switches that once for on and then again for off, because what you'll see is that there and there are identical. All it does is it's the equivalent of me clicking. That's all that is. Then what it does is it now knows it needs to set up an object. So this is what's called a mid-declaration object. And all it actually does is it defines this object for me to apply it into a specific space. So if I just come back across, what you'll see is we've got the part segment, create line. Now we have 6 values. Is everybody clear why there are 6 values? Does anybody know what these 6 values are?
Is it value transformed in the system?
It is. It is. I was just checking. But yes, it is. We have 3-point axes. So we have X, Y, Z to the start of the line, X, Y, Z to the end of the line. The overall coordinates of the whole thing. So if I snap that back and then click F8 again, clear the selection because you'll notice it's blue. No need to have this highlighted blue anymore. Now what you'll see there is we've got part sketch manager, insert sketch, same command as that, snaps it out. Right, so now when I did it, it was only a short line that I drew. So if I edit that, I can take an awful lot from this that you see. If I edit that, and then I'll go to Smart Dimension. It's 122 millimeters. That is monstrous in comparison to what I drew. It's far out of scale of what I did. So that then leads us to the next point of experimentation with this. If I go to here and then go 1, just change that to 1, then we should be able to figure out what the scale would be. So let me just slip this back, and I'll delete that, and let me snap that across, and let's run that again. So if I come back, and then again I'll right click, edit, smart dimension. It's 1,000 millimeters. So what does that tell you about the coding system? The only reason I do this is this catches students out on their assignment every single year. It is an absolute stump, and it really gets students annoyed every single year. I'll show you. I put in 1. It came back at 1,000 millimeters, exactly, Vegas. Came back at 1,000 millimeters. It instantly tells you that the default units that this thing uses is meters. Always keep that in mind. Don't fool yourself, because I had one student one year go, it's alright, what I'm going to do is set the units inside of SolidWorks and it'll be fine. No, it won't. It really won't. So what I always say is always keep that in mind. It is meters, radians. It is not in angles that this thing operates in. It's purely on radians. So always keep that in mind. So if you wanted, obviously if you wanted 1 mil from that, you would just put it out as 1 divided by 1,000. Then you instantly end up with your 1 millimeter. It's important to keep that in mind, and it's important to get used to doing that. Right. Now, it's alright drawing a line. It's alright, you know, just doing the basic process like that. But how are we going to how are we going to actually turn this into something useful? How are we actually going to start to replicate this? What I want to do is just spend the next 25 minutes, something like that, 25 minutes, 30 minutes, something like that, on the construction of the line. I'm going to set variables, then I'm going to set you a challenge to solve within on the following 15 minutes. Then we're going to review on that challenge and see who actually solved it. But first things first, I'll take you through the process of being able to get some input from the user. So when you run these APIs, you always get a little box that says enter a value of 10 or enter your input lengths or things like that. So what I'll do first is I'm going to define myself a variable. So I'm going to set a dimension of x, because it's the x coordinate. You don't have to call it x, you could call it anything you want. I just call it that just because it reminds me which way I'm going, because if I end up with x, y, z coordinates, it'd be nice to know where the hell everything is. So I'm going to go x, and now it needs to know exactly what it's going to be. Is it going to be a Boolean where it's simply switched on or off? Is it going to be a long status where we can record large levels of accuracies to stop overloading of memory for crashing? Or is it going to be an object? But no, in this case, because we're going to be looking at millimeters, and because I'm going to get you to challenge you in different things, in this case I'm not going to set it as an integer. So if I type in, you see integer, I'm not going to set it as that. In this case, I'm going to set it as a floating value. Now, for those of you who are just unsure, your integer is your solid values, obviously your 1, 2, 3, 4. Your floating value is 32 bits past the decimal place. However, if I declare a double floating value, I can have 64 bits past the decimal place. Now, I think last time I think the furthest that they've ever got is something like 1 trillion digits past the decimal place before they just could not record anything else. But don't worry, we're not going that far. So I'm just going to type in double, because this is a shortened version of the floating value. So basically, it's a double floater. Now, always keep in mind that this software is stupid, really stupid. So what I'm going to do is set this up, and then I'm going to recreate this with something wrong with it. So what I'll do first is say x is equal to input box. Now input box is a direct command. All this, by the way, is in the notes that's attached. So I'm going to input box, open bracket. Now when I go input box, it literally says enter a prompt. No quotation, and I will go enter line length. Define it as millimeters. Close that. Now if I go comma, just like what you get in Excel, when you comma something, you'll see that different areas become bold. So if I go title, for example, X value input, I'll call it. And then what I want to do as well is I'm going to put a default value in there. I'll put a default value of 1 in there. And now that's me. I'm good. So I'll close that off with a second argument. Now, there's a few ways of being able to do this. You've got to think, if I put 1 in there, that will be 1 meter. I've asked the user to input in millimeters. That means instantly, if I do something wrong here, if I don't change it, they're going to input 1. It's going to come out in meters or 500 and so forth. So what I'll do is, once I get to the end of here, I'm going to divide whatever they put in by 1,000. Yep, so I'm going to input that and change that by 1,000. And now I'm going to actually edit that and change that to X. Simple as that. And save. So now, if I'm going to need to delete this again, because it won't automatically know. It will just keep making sketch after sketch. So if I run that again, and I'm just going to say 50. Good question. Good question. I'll answer that. So why they divided by 1,000 is not inside of here, because best way to do that is think of it as an if statement from an Excel spreadsheet. With an if statement, anything that's inside of the argument is part of that if. So you'll notice the actual command here is input box. So this means whatever comes in when I ask the user for something, that is what they're going to see. Once the user's then delivered a value to it, no matter what they put in, I want to divide it by 1,000, because that then it will always make sure that it's in millimeters, because don't forget, it defaults itself to meters. So I'm instantly in control of that, regardless of how stupid they want to be with it. I'm instantly in control of that, but that is why that sits there. Simple as that. Right, so it's come in, it's 50mm, happy days, it works, not a problem at all. Right, so that is a simple working example. Simple working example. So what I'm going to do is recreate it. The one thing that I told you before, that this system is stupid. It is very, very stupid. If I click on new part, now I'm just going to maximize that. If I go record, then go to sketch, and I'll go right plane in this case. I'll go line from the origin to there. And that was all I did. Click stop and override that. Now, I'm going to go to edit, onto line. So if we look, right, now if you remember in there, I didn't need them. So they're gone. There, didn't need them. So that's the code I'm going to operate with. One thing I didn't explain to you very well is the select by ID. Select by ID is literally saying select this system, but what it needs to know is it needs to know what it's called, what it is, and where it is. So what it's called, what it is, and where it is. So that was me clicking on the screen. Then what it needs to do is it needs to assign it with an understanding of what it's going to be. So in this case, it's a point of reference. It is not going to be used as geometric identifiers. So it's set to a false. So in essence, what it's saying is you can use this temporarily, but it won't be used as anything geometrically sound. Hence why it gets set to almost set to a nothing. These are Boolean declarations. Simple, true, false, nothing. What else do we have? Yeah, or a nothing. Which in itself, as I said, the nothing is just to define that it's not actually used as something key in that way. Right. As I said, when I'm running these codes, never do I ever run them. Do I start editing from the start? Because if you start editing and you run it and it don't work, you kind of go, you just think, what the hell has happened? So if I hit run, so there's a spot. Okay, so we've got a spot. I go there, there, and there. That's how it's seen, but that is not how I drew it. Does anybody have any idea what I did wrong? Don't worry, I will explain to you. Just wanted to really test why that did not work. This is again, I say it's students, it's not just students. I've seen people do this loads of times and go, it's well crap, it won't work, it doesn't, it does work. It was actually me that did something wrong, and it's not 100% clear what I did wrong. So let's go back to the idea of this software being extremely stupid, because it is. One thing I did really, I should have stepped through this, but the only reason I hit run is that I wanted it to be blatantly obvious that I'd done something wrong. So I'll go F8, main menu, set the application, set the active document, insert sketch, right plane. So it's stupid. Remember, it is, well, I suppose it's not stupid. I'm stupid for messing with it the wrong way. Think of it like this. Let's say, sorry Harry, I'm just going to pick on you for a second. Let's say I just walk up to Harry and say, right Harry, draw me a picture. Then instant response with that is, okay, where, on what, how do you want me to do it? Now, interestingly, I do this normally in the classroom because it's much easier in the classroom. Normally, when I say to a student, draw me a picture, what they'll instantly do is reach for the bag to get a piece of paper out, which is fine. That is your default thought of that's where I can do it. Right, if we pan this straight back to the beginning again, this tells us an awful lot. If I pan this back to the beginning again, and I run it through, shit, wrong button. So there we go. If we go F8, steps it in, steps it in, steps in. Right, see where it goes to. Part Sketch Manager, insert sketch. That is me saying to SolidWorks, make me a sketch. What SolidWorks does is says, I have no idea where the hell you want me to put it, so what I'm going to do is use my default answer, the front plane. It clicks itself automatically onto the front plane. Then I've said to SolidWorks, it's okay, put it on the right plane. SolidWorks goes, yeah, very good, that's the right plane, but I'm already in a sketch, so I can't do anything. So it stays in that sketch, adds the line, clears selection, and inserts the sketch. And it's simply because shortcuts. Shortcuts are what do this. So I'm going to run you through the process of what I did that was wrong. So if I go back, best way to consider this is you've got to treat this like this is the first time you've ever used CAD and you do everything prim and proper. This system will even pick up on your shortcuts, so hitting escape or going straight to sketch. So you have a few go straight to extrude, which automatically goes to sketch, which automatically goes to plane. But what it will do is it will record you doing that. So what I did wrong is I came into here and went, right, sketch. Then I've clicked onto sketch and then I've chosen where to put it. And that is what's left it confused. Simple as that. So what I'll now do then is I'll go back to the code and re-examine how I could fix it. And it really is this simple. That's where the right plane is selected. If I simply say, choose the right plane first, and then insert me a sketch. So if I come back, and all I've done is swap the two lines around. Right plane selected, inserts a sketch, and now let me just check. It's on the right plane, as it should be. So this is just its way for navigating around. Right, so yeah, I've had an email about the very confusing instructions that everybody's received. It's okay, it's okay. I will get this cleared up for you. Don't worry. Right. So now, if I'm now going to quickly add my dimension to there, so I'll go dim x as this, Martin, is the code. This is built in. This is built into Excel. It's built into Word. It's Visual Basic. So when you click on Edit on SolidWorks on the macro, when you click onto Edit, it will open it up. Whatever you do, don't ever try and double click them. So I'll show you. So in here, this is the Visual Basic editor. Now, again, if you want to use, if you're more competent, you're more than welcome to use Visual Studio. But if you've never used it, don't even try it. Just go Visual Basic. And again, this is built into this. So it's already sitting here as a compiler. Right click, toolbars, macro. Right, so we come back onto here, and I've added dimension X as a double, and what I'll do is go X equals MSG box. Now MSG box is a very similar one as well. So before I used input box, I used MSG box. These are really good for design and for designing up what you want to do. MSG box just makes life a little bit easier on a few things. So I'm just going to be throwing in different ones just for you to get used to using them. So I'm just going to go enter line length in. Then because we have meters as a default and we have radians as a default, I'm going to divide my whatever the user inputs by 1,000, and I'm going to change my endpoint of the x coordinates to simply x. So let me just check that, make sure it runs. Oh shoot! 1 second. I'm just thinking it's not an MSG box because it's just message. Silly sod. Sorry, that's my mistake. So I'll go 10. So I'm into 10 millimeters. Code's running, it's doing its job. Again, simply a line at the moment. Now, what I am going to do is challenge you. There is a lot to be learned in simply this line. So what I want you to do is simply this. I want you to recreate what I've just done here. Then once you've recreated what I've just done here, I want you to try and make the smallest line that you can. When you can no longer make a small line, will you please put a message onto the team chat as the smallest line that you can record. It sounds crazy, it sounds daft, but there is a massive thing underlining this. So I will give you 5 minutes. Again, recreate this. You have 5 minutes to try and create the smallest line that you can. If you're struggling, please do let me know. As I said, you have 5 minutes, so we'll go 2 minutes past 12. So you have 5 minutes starting from. Let's take a look. So this is what I was asking for. Now what I was asking is type in the smallest line that you can create. Sounds crazy, I know. Sounds a bit daft, I know. But let's move in and let's just take a look at the smallest line that you can create. So what I'll do is I'll type in, I don't know, 1. Okay. So then I'll go 0.1. I think 0.1 millimeters. Okay. What if I go 0.2? So you look at 0.2. So if I zoom that in, yeah, okay, that's fine. So let me just try that again then. Let's go 0.1. 0.1 now works. Still like that. Let's go even smaller. 0.01. Now it's working. This is one of the pains in the backside. This is one of the things that you're going to face in your assignment, by the way. If anybody's unsure, I am going to ask you to API code some geometry. And it will be less arty-farty like the surface assignment is, where it's kind of like this or roughly that size. This will all be specifics. Every value you use must be justified by the genuine article. Cannot be made up. Right. So what's happening? Has anybody any idea why that happens? It's okay if you don't. It's I was just curious as to who might know. Right. So
Is it decimal places by any chance?
it's a good answer. It is a good answer. It's not, but it is. It's a good answer. So if I go back to 0.01, if I go 0.01, doesn't seem to work. Now, the only reason I say this a lot is just because not a lot of you will remember it just because you're a bit younger, which makes me sick. But I'm going to snap this in. This is still apparent, which is nice. See the grid. Now, those of you who are CAD savvy will know that the grid, you can create snaps, right? Now, we'd be able to create snaps. The grid reference is defined by the geometric zoom that's on it, and it's as simple as that. So if we put this into a terms of a drawing, so you have to excuse my awful drawing on this. It's not the best thing to draw on, but if I draw a line, and then let's say we have a snap. If I draw a line that is between there and there, bring that to the front. If I draw a line between there and there, what you get is a system that can recognize where these points are, and it will know what to do. However, if I then draw a line, so this is all geometric referencing. If I draw a line which is inside of a single snap area, what it's actually going to do is go, no one would draw that size. It's going to snap these two together, and it's going to delete itself because it's going to think it's a line when it's actually not. So if we refer this back to the actual image from here, see where these sections are. These you can kind of just see that you've got your sub-reference points here. And what this is snaps. Snaps are what do it. So there is ways around this. Of course there's ways around this. If I do this again, 0.1, and then if I zoom to there, and then run it again, 0.001, we're starting to get that overall effect. So that process, it will work. It will work. However, what if I don't want to do it like that? So this would only work under the idea of that if you're drawing some process and you want to put a particular marking, if you want to put a CE marking on the geometry, automatically when it runs through, you're going to have to zoom to that area to draw it, but you might not want to. What you could do if you wanted is you could turn the snaps off. So if I just hit record and then go to options, snaps, click OK, and then stop. I always rename files that are a lot of crap to just be dummy, so at least then I don't accidentally overwrite things, because in my life I've done that a million times. So if I go to edit and go to dummy, what you see now is, again, these are obsolete, these are obsolete, this is your deactivation of snaps. So I could simply deactivate the snaps, and that would allow the line to be drawn no matter how zoomed out I was, because what it would do is it would not allow it to have that snapping function anymore. The trouble is if I'm doing line to line to line to create a triangulated shape or a rectangular shape, snaps allows you to automatically create relations between two lines. So what you really got to do is decide which way you want to go with it. For me personally, I've always just used zoom. So an alternate to do it is, I'll need to switch back on my snaps. An alternate way of doing this is if I go to snaps, I'll turn these back on, and then again let me just draw a line. In fact, I'll run the code through, because at least then I can make sure that it's running as I wanted it to. So I hit run, 0.21, oh, 0.1, wow, it's quite far zoomed out, 1, 10. Right, so what I've often done in the past is if I go record and I'll go to, see you got zoom to area, so if I zoom to that area and then hit stop, go to dummy, put it into there, because again it's just crap, it's just bits of stuff I'm pulling out. But if I go into there and then onto here, we've got that as a coordinate. The only way you can know that coordinate is once you start to build up many identifying variables. It's the only way that you'll ever know it. It's the only way that you can ever do it, is to know what that is. So there is no direct straight answer to solving that problem. It is one that you will face, but you just to decide where you need it and where you don't need it. And how you want to attack it. But again, for me, I've always used part zoom. But the pain in the backside with it is creating that automatic zoom, because you've got to remember, if you're using variables, everything's moving, everything's changing in position. Right, so next challenge. What I'm going to do is I'm going to create a shape and I want you to make it. And then we will solve it, but I want you to make the shape. So what I'll do first is go to, now I'm not recording this, so I can do things, daft stuff like that. So I'm going to go right. What I want you to do is create a shape which is variably controlled, which creates that. Simply create that shape. The code that we've already made, interestingly, with this code, you can actually remake, not that code, it's awkward. With this code, you can actually make that shape dead easily with two variables. I want the X and Y to be variably controlled, so X and Y, the points to be variably controlled, but recreate that shape. As I said before, you have 10 minutes. So have a go at it. I literally have my watch on to be timing, so there you go. I'm going to give you 10 minutes to have a go. If you are struggling, please do say, and I will gladly take you through the processes. But if not, as I said, you have 10 minutes to create that code and get it fully running, starting from now. So let's continue then. I'm going to close that, and I'm going to take you through, not even through SolidWorks at all. We're just going to leave it there for the minute, just so we can approach the code and just look at what it's telling us. So that's the code. Now, what I was saying is let's first think about, that's what they're asking for. So on here, I'm going to go comma. I'm going to give it a title of X length. There is a reason I'm doing that. And let's stick a default in there. I'll give it 10 millimeters. Oh, 10 millimeters. So, what did I miss? Oh, tell you what I did. Forgot to put it into quotation. Because when it's in a quotation, it will take that as a label and bang it on where it's been assigned to. So what I'll do here is go dim y as a double. This is probably one of the only things that you're going to get away with copy and pasting like you wouldn't believe. I'm going to copy all of that, copy, and I'm going to paste. Change that to y, and I'm going to change that also to y. And that now is my new variable. Now there is such a sneaky way of being able to do this. It's ace. I love it. So I'm going to make a little bit of space. Now when I'm normally editing stuff, just because I'm aware of that, stuff can go wrong all the time. I like to give myself a little bit of like a boom, that's where it is. Or else if it's too neat, you kind of look and get confused. So what I'm going to do is I'm going to copy this line, paste, and paste. I know I'm going to put 3 lines on. Simple as that. So if I think about the geometry, it goes from 0, along 0, and then from there up to the Y position, and then back home again. So what I'm going to do is, thinking about that tells me one thing. If you think about dot to dot, sounds crazy. As a kid, when you're doing dot to dot, you go dot 1 to dot 2, dot 2 to dot 3. As you're doing it, think of it as the exact same thing. So this is the first line. So this tells me this is dot 0 to dot 1. Then you'd often go dot 1 to dot 2. So that means that's the starting point. So if I copy that and paste it into here, that's dot 1 to dot 2. So dot 2 is dead straightforward. If you think about it, all I actually want to do now is I want to go dot 1 to dot 2. Dot 1 to dot 2. Now, just for completion, to close this line, I'm going to go dot 2 to dot 0. So my end of my line to that point. And that should be correct. So let's give it a whirl. I'll bring my SolidWorks back across. Go new part. And let's run it. So if I zoom in, could that be snaps? Let's run it again. Because I've zoomed it in now. Still not happening. So if I need to see what's happening, I'll tab. Now, tabbing into the border will actually interrupt it. So if I click onto it, it'll interrupt it. So it will run it and then stop it there, and I can step through the rest. So we'll click OK. We've got 10. So there's my first line. Oh, wrong button. Apologies. So press F8. So my middle line here wasn't doing its job. Has anybody oh, I hope somebody spotted that. Has anybody spotted it? Ah, good man. Yes, exactly. I wasn't sure how long it'd take. These are XYZ coordinates. I've got XYZ coordinates, but then don't forget these are XYZ coordinates. I put Y in where X is. Really, that should be 0, and that should be Y. Again, so this becomes 0, and that should be Y. Because what it was doing is it was looking at the two and going, it's exactly the same, because it was reading the variables, nothing more. That's all it was doing. So I'll run it back again. And then run it. So sometimes the smallest of things, the smallest little mistake can lead to such a screaming section where you just think, the hell is going on? Why is that happening? So if I run it again, I'll just go with the variable this time. Let's go 50. Let's go 20. And that will run at each time now. So that's solving that straightforward problem. Right, so let me just call up my notes. These are the notes, by the way, just in case you're unsure. These are the notes. These are all freed up today. We've just taken a look at this example. Now, the second one's a nice one, interesting one as well, because it allows us to introduce the next phase of this, extrusion. So what we're aiming to do is to create a hollow pipe. We're just creating a pipe, I should say, not a hollow pipe. And we're going to have it as a tube creator. What we essentially want to do is we want to have an outer diameter and we want an inner diameter and an extrusion. If you're brave enough, you can introduce a wall thickness. Now, don't get me wrong, at this point, there's going to be lots and lots of limitations within it, but I'm not going to answer the third one. The third one I'm going to leave to you, and then we will solve this next week. So this is tube creator. So we have an inner diameter and we have an outer diameter. And what we're looking to do is to recreate this in an extrusion. Now the extrusion bit we've not done yet. So what I'm going to do is work my way with it and take you through the process of being able to do it. Because then we've gone from simply a line, we've looked at the construction of the line, we've then multiplied this through to show that we can create geometry. The important thing about this is if I click onto here, by the way, you'll notice that it's been shaded. So these points have met. It means my snaps are on. If my snaps weren't on, these points would not be connected and I will be simply be able to move this line without the others responding to it. The other thing that you'll notice as well is that this isn't defined, purely because defining the sketch is for more of that construction process. If you're leading this by driven dimensions, you don't need to put dimensions onto here, because all your dimensions sit inside of here. The second that you use dimensions on this, it becomes a pain in the arse. It becomes more trickier than what you'd imagine. So what we're going to do is we're going to create a tube creator. If you've not done already, make sure you save anything that you've presently done. Not to be difficult, but I won't be uploading these codes. Not yet, anyway. Not until we're a good few weeks ahead of everything. So, coming back to the notes, what we essentially need to do is, you'll notice here, model a hollow cylinder produced by 2 sketches from the origins of the right, and extrude by 40 millimeters, and let's just get that ball rolling. So we need 2 sketches, 2 circles. One important thing to remember about geometry: when it's drawn in lines. Everything is drawn in lines. The process of everything is drawn in lines, and it is the method of command which allows it to be defined in many different ways. So if I go to record, I'm going to go to right plane, I'm going to go to sketch, going to go to circle, and you see how there's a construction line there? That construction line is what it's going to record. The command is a circle command. Now you don't need to worry about that. What you need to worry about is controlling the radius, because that is how these are controlled. So I'm going to go first circle, and I'll go second circle. Again, dimensions don't matter, because I'm going to define it. Now, if I've ever received anything like this before, I've always wanted to know drawings. When I get drawings, it's mint, because you can look and go, right, they've given me the variables that I'm going to work with straight away. I've instantly got OD, I've instantly got ID, and granted they give wall thickness, so I'll call this WT, just for argument's sake. Right, so, and then I'm going to stop, and I'm going to call this tube. And I'm going to go to edit, and then begin the process. Oh, this is because I've been going backwards and forwards. Oh yeah, you see, when you zoom, this is what you get. I shouldn't have zoomed. Ah, swine. If you haven't zoomed, good, because that is all you should have. That is everything that you should have. I shouldn't have zoomed. So if I just highlight all here as well and delete all that, and that is what you should have. Something like that. Something where you've got the plane selected, you've got the insert of the sketch, then you've got both circles put into position, and you'll notice here that we've got a slight off. That means when I drew the circle, it wasn't actually on the line correctly. Now, as I said, we've got 3 variables already ready to go: OD, ID, and WT. So I'm going to go dim OD as a double, dim ID as a double, dim WT as double, So, right, I could choose here where I want this to go. Some people like to have the plane glowing whilst it's drawing. It's purely up to you, really. For me, I like to put it just at the start, get the input, then draw it. So then what I'll do is I'll say let's have a look. OD is equal to input box. Open, and then what we'll say is enter counter dia millimeters. Over 1,000. ID is equal to input box. So I've asked the user for the diameter, but don't forget we're operating in radius. So if we're operating in radius, we're obviously going to have to take that value over 2 because they're going to be putting in the diameter. So this will easily lead to a confusion. I just want it to be the radius drawn from the center. So what I'll say is OD, replicate that process again, call this ID, and then save. And run it. Outer diameter, I'll go 50. Inner diameter, I will go 30. So let me try it. And that's happened because I forgot to put it over 2. So you look here, forgot to put it over 2. Now, a lot say you don't have to use arguments here. I always use arguments just because I like to be sure it's doing what I'm telling it to do. And again, this is purely because the user is inputting the diameter. So let's run that again. So I've got 50, 30. Just double check it. 50, 30. Right. So that's great. So this is the basic minimum to getting myself set up. Finally, the one thing I want to do is I want to create an extrusion. Now the beauty is when I ran that code, that is how it finished. Finished in that position. What I now want to be able to do is to create an extrusion from that. And the easiest and most simplest way of doing it is creating, as I like to think of it, is create like a bolt-on. So if I go to record, feature, extrude, and then click OK, then stop, and tube. Oh, no, sorry, that was me nearly messing things up. Go dummy, stick everything in dummy. Now if I go to my dummy folder, get rid of all that. We know, let's have a look. So trimetric view, we know that these are controlled with Cosmos, so we don't need that. It means that these functions here control our extrusion. So if I simply copy that and go back to here, paste that in, I'm going to put a default on here as well because I'm sick of having to press enter. So let's go a default of 30 and a default of 50. So if I run that through, so now we've got some geometry. Now in the criteria, what we needed to do was to set it to, let's have a look, 40 millimeters. Oh, no, sorry, that's the wrong one. Yeah, extruded by 40 millimeters. But ideally, we'd like to be able to have a variable control of that. We'd like to be able to have a variable update of that. But what I think I'll do is I will just set this to 40 millimeters, and then I'm going to save that and let you have a go at the rest of it. I do recommend that you have a go at this because it is very useful to get used to being able to navigate yourself around it. It is incredibly tricky. I'll quickly just show you though my features, part extrusion. All these true falses are all references to different tools. So draft functions, key location, directional functions. You've got angles. These are all recorded in radians. So then again, you've got further falses as opposed to the configuration setup. If you want to speed up the process of these configuration setup, you can simply just set it from SolidWorks, and then that will automatically set what was true and false in what you're doing. Now these are what the nickname is, start and end point extrusions. Think of it as a line again. So you have a start and an end point, and what it's referring to is drawing each start and end upwards. So you can do this with just one, but if you were doing a mid, you can actually get it so it'll extrude one side by 5 millimeters and the other by 15 millimeters. But for this, we just said it'd be 40 millimeters. So I'm going to change that to 4. And also change this to 4. So if I run that back, get back to here, delete onto there, delete, and delete. Run it again. $40 millimeters. So this has been a nice warm-up. If you haven't done this, please do this, because I'm going to call back up on this. We're going to use this again, and we're going to use this to add more particular detail into it. These are basic pieces of geometry, washers, if you will. The further that we move down into this, we're going to become more and more complicated geometry. We're going to examine the idea of threading, using threads. If you are creating geometry, I do expect you to literally rebuild threads from scratch. And granted that they're always set to a standard, but using that as a standard is vital. But using that as a standard is vital. So just get used to using it and being able to navigate yourself around it. As I said, this code is not just usable here. You can use it all over the place. You can have SolidWorks to MATLAB, SolidWorks to Excel, SolidWorks to text files and Reader. You can have the whole system talking to itself. If you're doing analysis, and part of your analysis that you're doing will decide the size of a kidney for valves. then you can get SolidWorks to automate itself. So if you have the overall XYZ, XY positions, you can get SolidWorks to read them in and build you the part based on the mathematical outputs that you're creating. So there's a lot of things that you can do with it, but this is a nice intro to get used to it. What I would say is have a go at introducing variable length, changing that extrusion, and then in the notes here, try and come up with a way to calculate the output for the volume of the material. So have a go. I'll stop recording just because we've digested quite a bit there and it's a nice intro. Is there any burning questions? So let me just hit stop.